Let's pivot to you. From the perspective of a geographer, you've studied the effects of climate on many different ecosystems, from forests and lakes to estuaries and oceans. Can you share with us your observations on how ecosystems are and will be impacted and how that could affect human society? Can you also comment on how ecosystems can serve as climate solutions?
Sure, thanks for the question and thanks for having me here. So I'm a boots on the ground field scientist, and I'm going to give you my perspective from the trenches, from the field, and why this initiative, the Climate Crossroads Initiative, is so important. I just want to say this isn't as though climate change is affecting some sort of pristine world where everything was going well. Folks, we've lost since 1500 CE over 800 known animal species. We've probably lost many, many more than that. UN has estimated that about 70% of the terrestrial land cover has been affected or altered by human activity, and that's having a huge effect on animals today. There was recently a study published by the World Wildlife Foundation, which looked at 5,200 species over 3,200 populations and found about a 69% decline. About 69% of these are declining in their population numbers. We take a look at things that I'm very familiar with, California and the Western United States in terms of fire. We saw in 2020 in the state of California, 4 million acres burnt. That was a huge, huge record. We've seen throughout the Western United States a long-term secular trend since the 1980s of increasing annual area burn, increasing fire severity. That is directly linked to increasing temperatures and increasing vapor pressure deficit, the dryness of the air. We see sea level rising. We see marine heat waves affecting our nearshore biota. Throughout the world, we're seeing effects of climate change on an already stressed system. So we have to take this extremely, extremely seriously. Now, I believe that ecosystems are at the nexus of this. And I'm thinking about engineering and I'm thinking about medicine. They are at the nexus of this. If we take a look at what those wildfires are doing, there was an estimate that in terms of communities, in terms of costs, in terms of economics, the 2018 wildfire season costs about, if you look at all the costs, about $180 billion. $33 billion of that were health-related costs. PM 2.5, fine particulate matter from smoke, is becoming a huge hazard. I don't have to tell anyone on the East Coast about that. I don't have to tell anyone in California about that, where we're seeing rates of pediatric emphysema, for example, being exacerbated by this. Emergency room hospital visits being exacerbated by this. The rising sea level is causing problems for coastal engineering. We are going to have to move the main line from the railroad track that goes from San Diego to Seattle inland because it is now threatened. So what's happening to our ecosystems, whether they're coastal, whether they're forests, they are at a nexus of what we see happening with climate change. If we take a look at the health of our cities, we think about polar bears, and that was mentioned. We're not talking about a crisis for polar bears. We're talking about a crisis for the planet. And I mean urban as well as rural. If we take a look at what's happening with the drying out of California, we were doing remote sensing studies of browning of the natural vegetation, and we will filter out the cities. We started looking at the cities, and what we see is there is a browning going on because of the high temperatures and because of water restrictions that we've had. Where is that concentrated? Communities of color, socio-demographic areas of lower income. We are seeing then inequality. And that came up this morning when we heard from the presidents. And that is a medical issue as well as an engineering issue. How do we keep our cities cooler? Because where we're seeing that loss of urban vegetation, we're seeing increasing urban heat island. And again, how we counteract that, there's medical implications, but there's also engineering implications. Now, can natural systems be part of the solution? They can be if we can increase the rate at which carbon is sequestered, or at least protect the rate at which carbon is being sequestered in these systems. There have been a number of studies. I was very fortunate to lead one in Canada, which had 19 scientists and looked at the potential for ecosystems to sequester carbon in Canada, Canadian ecosystems. And this was over 300 pages looking at that issue. I'm not going to bore you with the details, but I'll say this. This has been studied in the United States, it's been studied in Canada, it's been studied worldwide. The United States, one estimate is about 21% of annual emissions could be taken out of the atmosphere by enhanced carbon sequestration from natural ecosystems. Forests, better agricultural practices, rangelands, protection of grasslands, things like that. Worldwide, there's an estimate that about 30% could be sequestered. The vast majority of that, though, the highest amounts, would be in the tropical regions, in the global south. And again, we then get at the international aspect of this. Canada itself, despite its vast agricultural and forest areas, we calculated about 6 to 12%. Now, that may not sound big to you, 21% for the United States, 6 to 12% for Canada. But that is huge. That's larger than a lot of smaller countries produce in terms of greenhouse gas emissions. It would basically negate the emissions from all the stationary plants in Canada if we could take advantage of that. And we can talk later about the challenges. But there is opportunities there, but I also want to say there's huge challenges in that. Finally, if we don't do this, if we don't work at enhancing and protecting the ability of our natural carbon sequestration systems, our ecosystems, we are facing a carbon bomb. For example, if we take a look at peatlands, global peatlands, there's somewhere about 600 to 760 gigatons of carbon, which is stored in those systems. That's getting close to the amount that's in the atmosphere. With warming, we will see that released, perhaps as methane, perhaps directly as carbon through fires and aerobic decomposition. We're sitting on huge stocks of carbon in our natural systems, which we could release, and we have to battle against that. Those wildfires in Canada that are burning, about 76,000 square kilometers, released about up to now, and still counting, 160 million tons of carbon. We have to tackle this issue.